Welcome back. This is the second lesson recording for IM1 of September 15th, 2020. And for this recording, I am going to go over the homework that was due today, as well as homework that was due last lesson. And I'm doing this pretty thoroughly for those of you who are still struggling a little bit with this concept. Okay, so this problem asks you to draw in arrows to describe increasing and decreasing behavior, and then to describe in words and inequality notation the domain and range of the graph. So the first graph looks like this. The black is the original graph. Now, when we're talking about increasing and decreasing, the arrows will always go from left to right because we are reading from left to right. So as you go from left to right, the arrow is always going to go from left to right. However, it's going to go up or down depending on what the graph is doing. And in this case, the y value is decreasing first. So it's decreasing, the arrow is pointing down. And then from here onwards, it's increasing. Okay? Now let's do domain and range. Let's do domain. Domain is all possible x values, right? So that means I just shaded in just like we did in Desmos and just covered up where the graph extends. It extends. This is the minimal value. This is the maximum value. Minimal value was -2. Maximum was +4. So I can say that domain is all real numbers between -2 to 4. And in inequality, I need to write the smaller number just like you see it on the number line here. The smaller number is on the left, the bigger number is on the right. So -2, +4. We're talking about domain. And remember, docs tells us domain is all the possible x values. So x is in the middle here. The inequality is opening to the right. And because this is a closed circle, is less than or equal to for both inequality. Okay, so that was the first graph. Let's look at the second graph. Second graph looks like this. It's just simply this graph just goes from this point to this point. It's just decreasing. Again, when the arrows need to always go from left to right. So in this case, it's decreasing. Domain, so yellow tells me how far the x value on the x extent, how far the graph extends on the x axis, and extends from +1 here all the way to +4. So it's between +1 and +4. And how do I write that as an inequality? The smaller number is on the left, the bigger number is on the right, and we're dealing with domain, so it's the x in the middle is less. So 1 is less than or equal to x is less than or equal to 4, which tells us that it's between +1 and 4. Okay, what about range? Range, I don't think we did the range for the first one. Okay, range, again this time I shaded in the vertical, the y-axis values. So that's my blue shading. And the blue shading tells me that the minimum value that I have on the y-axis is 0 and the maximum is 2 when I shaded in and covered up the whole graph. So the range is all real numbers between 0 to 2. And how do I write that? It's 0 and 2. With y in the middle because we're talking about range. Remember our friend Docs and Ray. And so it's going to be 0 is less than or equal to y is less than or equal to 2. The inequality is always going to be opening to the right, never to the left. Okay, and then the second problem, again, I shaded in just like we did in Desmos and figured out the minimum was -3 here and the maximum was +3. Okay, so the range is all real numbers between -3 and 3, and you would write as -3 is less than or equal to y is less than or equal to 3. Okay, let's go on to the next two problems, and I am going to show you so that you can see. Alright, so again, this is non-linear, this because it's curved. it starts off increasing, and then at the maximum point here, then from there on it starts decreasing. If I was to draw, shade in and box where the graphic stands, this tells me where the minimum value on the x-axis is -2 here, and the maximum is +4. So it extends from -2 to +4. We're talking about domain, so x is in the middle. So domain is all real numbers between -2 to 4. Range is the vertical, right? The vertical extends from, it's not quite 2, I would say -1.8 to +1.8. So its range is all real numbers between -1.8 and +1.8. Okay? And I'll write it like this. And then lastly, again, I drew a box to enclose the whole graph. The maximum the graph extends and the minimum graph extends on the x-axis and the y-axis. And the x-axis extent tells me the domain. Domain goes from, this is -2 here, -2, and then +2, +2. So domain is all real numbers between -2 and +2. And you write it as -2 is less than or equal to x is less than or equal to 2. And then range is the y-axis, the y values. Remember dox and ray. Range is all possible y values. So range, the minimum value here is probably about -0.5, maybe a little less, to about 2.5 will be my guess. So it goes from -0.5 to 2.5. So I'll write it as -0.5 is less than or equal to y is less than or equal to 2.5. Again, the smaller number is on the left, the bigger number is on the right. It's the x or y depending on whether we are talking about domain or range in the middle, and the inequality is always pointing to the right. Okay, so this is the homework that was due last lesson. I'm going to go through the answers again. I actually did this as warm-up, but let's go through it a little bit more slowly. Okay, f of x is same as y. Remember we saw that video and telling us that f of x and y, it's same thing, okay? But this f of x, the function notation, allows us to write things in a little bit more efficient way, and that is the reason we are dealing with f of x. And f of x is same as y. So this y-axis is really just the output, or f of x, and the x-axis is the input. And when you see f of -4 here, remember the number inside is the x here. So this is the input. And this f of -4 is the output. Together is the output, or the y value. The input is the x value, the output is the y value. So input is -4, or the x value is -4. Find your x to be -4. Then find your graph. Graph is right there. What is the y value of this point? It's -2. So it's going to be -2 here. Oh, no, I'm sorry. It's +2. This, what am I saying? This is +2 right here. So this is +2. What about f of 3? That means the input, the x value is 3. Where is 3 here? 1, 2, 3. X is 3 is here. That means where is the graph? Graph is right here. What is the y value of this point? Y value is, let's see, this is -1, -1.8 will be, or something like that. F of 0. F of 0 means that x value is 0. X is 0. Where is the y? Y is right at 0 as well. It's not the y value, the vertical position is also 0. What about f of -5? Where is -5? X is -5 is here, and the graph is again at 0. The y value is again at 0 because we're talking about this point. Okay? Let's move. And for what value of x is f of x 2? F of x is 2. F of x is 2. Now f of x is the output. When is the output or the y value? This is same as y value. When is the y value 2? It is over here. Okay, so we said that when x was -4, Is that the only time that the graph is at, the output is at 2? No, we have another point right here, right? What is the x value? If I just bring it down, I would say it's a little bit less than -1. So maybe negative 0.8 or something like that. So when you have two different times when the output is positive 2. Okay, let's move on to number 2. Okay, so now this time this is the g of t. Okay, and this should be g of x. Okay, and input is -2. That means find your x to be -2. This is my -2 here. And what is the y value? It's asking for the output of the y value at this point on the graph is 0. It's 0, 0. What about g of 0? G of 0. G of 0 means the input is 0. Where is the x is 0? X is 0 is right here. And the graph is also again at 0 here. So remember, the point coordinate here is 0, 0. And when you see this is the x value and this is the y value. And it's asking you what is the output, what is the y value when input is 0? It's just 0. What about g of -1? -1, that means input is, or the x value is -1. X is -1 is down here. And so go find the graph, and the graph is right at this point. And the coordinate for this will be -1, -2. Again, this is the x value, this is the y value. So the y value is -2. Okay? Now the question is, what value of t is g of t is equal to 6? To do that, this time this is the output, or the y value is 6. So find my y value, go on to the y-axis, find your y value here, and then there is one point here, and there is another point here. So there are two different points on the graph when the output is +6. So you go straight down, and x is what? X is 1 here, and then straight down to figure out the x is -3 here. Great. All right, then the next question is, the swine flu is infecting pork pollers. The function is S of t is 20t plus 15 models. How many pigs have swine flu after t days? What does S of 4 represent in this situation? So t is number of days. And that's the input. So S of 4, S of t together represents number of pigs infected. Okay, so I'm running out of time, so I wrote the answers down so I can go through a little quicker. All right, so that S of t is 20t plus 15. That's what we're told. And t is the number of days. That's the input. And S of t is the output. So S of 4 it just means that represents the number of pigs infected after 4 days. So then S of 4 is just plugging in number 4 for t every time you see that, and then it simplifies to 95. Okay, that means there were 95 pigs infected after 4 days. For S of 10, instead of 4 days, now we're looking at after 10 days, right? And so again, we are plugging back into the original equation. Instead of t, wherever I see t, I'm going to put in 10. And this is what you get, and you get 215. And that means that there were 215 pigs infected after 10 days. And then finally, the challenge optional question asks you, when the output is 215. Well, we found that 215 was after 10 days. So really, you could say that after 10 days, there were 215 pigs infected. That's what it means. Okay? All right. Thank you for watching, and we'll continue with the lesson.